If you have ever waded into a southern river, this is what you shared it with, and you never saw it. The alligator snapping turtle sits on the bottom, mouth open, moving one small piece of tissue inside it. The tissue looks exactly like a worm, and it is the animal's entire fishing method. Biologists believe it is the only prey capture lure inside any living reptile's mouth. But that lure is not the strangest part. Everybody repeats a bite force number for this animal, and it is not what the measurements say. Fixing it leads somewhere worse. The Atchafalaya Basin, south-central Louisiana. Tannin-stained water over a bottom of silt and drowned timber, with visibility measured in inches. There is an animal down there right now with its jaws open, and the only thing about it that is moving is that one pink flap. Anatomically, the flap is an appendage attached to the tongue, sitting on the floor of the mouth. In hatchlings, it carries no pigment at all and looks bright red. In juveniles and adults, the pigment comes in, and it goes pink or gray, depending on the turtle. The animal can hold it still, and it can make it move, and when it moves, it does not look like a piece of a turtle. It looks like something small and alive going about its business on the river bottom. Now put that inside the mouth it lives in. The Florida Fish and Wildlife Conservation Commission records a detail about this species that changes how the whole thing reads. The inner lining of the mouth is gray or brown with black splotches, which is different from most turtles because most turtles have a pink lining in there. So the inside of this animal's mouth is camouflage. A fish looking into it from a foot away sees more river bottom, with one small pink thing moving in the middle of it. In 2023, researchers with the U.S. Geological Survey published a paper on these lures in the journal Southeastern Naturalist, and the line they open with is the one worth holding on to. The lingual lures of this genus are believed to be the only prey capturing lures inside the mouths of modern reptiles. Not the only one in North America. The only one, anywhere, in any living reptile. Plenty of animals use bait. Certain snakes twitch the tip of the tail to pull something in close, and deep-sea anglerfish dangle a glowing lure out in front of their own mouths. What makes this turtle different is the location. The bait is already inside the trap, past the beak, on the wrong side of the jaws. A fish that comes to inspect it has to put its head where the jaws are. Which raises the obvious question. Does it work? And does the turtle have to learn how to do it? That got tested a long time ago. A 1979 paper titled "Luring in the Neonate Alligator Snapping Turtle" broke the whole behavior into 4 phases: waiting, luring, attack, and prey handling. The observations came from 8 newborn turtles, then 14 more turtles, all of them ingestively naive, meaning they had never taken a live fish in their lives, were run through experiments to work out what actually triggers the luring and the strike. Visual cues, chemical cues, mechanical cues, tested separately to find out which of them the animal is actually responding to. Newborn turtles. Never fed a live fish. And the luring was already there. That is the part that changes how you see the animal. Nobody teaches it. It comes out of the egg with the equipment and the routine. And the first time a minnow drifts past its face, it already knows what to do with its tongue. Here's what that looks like in practice, and it is slower than anything you have ever seen a predator do. The turtle settles into the mud or into a root wad or up under a cut bank, and it stops. The shell is already crusted with algae and silt, and against a Louisiana bayou bottom, that shell reads as a rock. Then the mouth opens, and it stays open. And then, nothing. For a long time, nothing at all, except that one small movement inside. The fish that gets caught is not ambushed the way a gaur or a bass ambushes something. It swims in. It sees a worm, it comes to look at the worm, and it puts its own head inside the strike arc. By the time the jaws close, the fish has done most of the work. That is why this animal is essentially invisible. In water, people use every summer. It has no reason to move. Speed is not part of the strategy. Chasing is not part of the strategy. And being seen would ruin the whole thing. A boat passes over it. A kid swims past it. A guy wades in to unhook a trot line, and the turtle simply does not react. Not moving is not a mood. Not moving is the hunt. Which brings up a fair question. If the entire feeding strategy runs through one small piece of soft tissue, how fragile is it? The 2023 Lure paper is the first published assessment of that. And the answer surprised the people doing the counting. Across more than 2,000 lure assessments in 4 states, they recorded 25 turtles with a damaged or missing lure, 7 adults and 18 juveniles, out of 2,000. So the piece of equipment that this animal's entire diet depends on, a soft pink flap of tissue sitting in the middle of a mouthful of hooked beak, almost never gets wrecked. Whatever the turtle is doing when it snaps down, it is not chewing up its own bait. So, how would you know if one of these is in the water where you live? Start with the range, because it is wider than the Louisiana bayou picture suggests. Florida's Wildlife Commission puts this species in rivers, lakes, backwater swamps, and sometimes in brackish water where fresh and salt mix, from Florida west to Texas and north as far as Illinois. That is most of the drainage of the eastern half of the country. Not the Suwannee, not one famous bayou. 10 states plus. Then the shell, because this is where people get it wrong. The common snapping turtle, the ordinary one that lives in farm ponds and drainage ditches across the eastern United States, has a relatively smooth back. The alligator snapping turtle has 3 rows of raised spines running the length of the shell, so the whole back reads as ridged and armored, usually under a coat of algae. The head is proportionally huge and triangular, and the upper jaw finishes in a hook, and the size gap is not close. This is the largest freshwater turtle in North America. Florida's Wildlife Commission, citing the work of Ewart and of Pritchard, puts a large male at 29 inches of shell length and 249 pounds. A wild common snapping turtle is a fraction of that. One thing I want from you before the next part. Tell me what water you are actually near. Not the famous river in your state, the one you personally swim in, or fish, or drive over on the way to work. State and name in the comments. I read every one of them, and that list is how I pick which places get covered next. Now back to that size, because everything after this point depends on it. Those numbers from Florida's Wildlife Commission come with a detail attached. The 249-pound figure is for males. Females top out around 22 inches of shell and 62 pounds. So the animal in your head, the 200-pound one with the beak, is a specific and fairly rare version of this species, and it is the version every video on the internet uses to make its point. Because once you have a 200-pound turtle with a hooked jaw, somebody is going to put a number on the bite. You have heard it. It's on every list video, every aquarium placard, every comment section. Roughly 1,000. 1,000 pounds of pressure. 1,000 pounds per square inch. Strong enough to take a hand off, strong enough to go through bone, and it gets repeated with total confidence. So let's go check it against the actual measurements, because this is where it falls apart. First problem, and it is a big one. That figure almost always shows up as psi, which is pounds per square inch. Psi is a unit of pressure. Bite force, in every published study of this species, is measured in newtons, which is a unit of force. Those are not the same thing. Pressure is force spread over an area, so to turn a bite force into a pounds per square inch figure, you would need to know exactly how much surface of that beak is in contact with whatever it just closed on, and that changes with every bite. Bite down on a fishing rod, and you get one number. Bite down on a crayfish, and you get another. No published study of the alligator snapping turtle reports a pounds per square inch figure at all. The most repeated fact about this animal is being stated in a unit nobody measured it in. Second problem is the number itself. Go back to 2002. A study in the Journal of Evolutionary Biology measured bite force across a large set of turtle species, and it included 5 alligator snapping turtles. Their average bite force came out at 158 newtons. In the same table, 11 common snapping turtles, the ordinary snapper that lives in ponds all over the eastern United States, averaged 209 newtons. Read that again. For years, the headline published measurement had the alligator snapping turtle biting weaker than a common snapper. There is a reason for that, and the reason is the whole story. Those 5 alligator snappers were small. Their average shell length was about 5.5 inches, and their average weight was under a pound. They were babies. Nobody had measured the 200-pound version because getting a 200-pound snapping turtle to bite a force transducer on command is a genuinely difficult afternoon. Then it got measured properly. A 2021 master's thesis out of Missouri State University tested bite performance in alligator snapping turtles in Oklahoma, and it split them by where they had lived. Free-ranging wild turtles produced bite forces from about 69 newtons up to 814 newtons. Captive raised turtles from the same Head Start program produced 6 newtons up to 334 newtons. It is the same species and the same measurement, and the wild ones bit harder across the board. The ones that had spent their lives in indoor tanks bit weakest of all. So, even where the animal grew up, change is the answer you get. And then, in 2023, the journal Southeastern Naturalist published the biggest run yet. 62 alligator snapping turtles and 33 common snapping turtles measured across an entire growth series from hatchlings to adults. The bite forces they recorded ran from about 8 newtons at the bottom to roughly 1,872 newtons at the top. So the top end is real. A very large adult can bite extremely hard. But look at what that spread is telling you. From 8 to nearly 1,900 inside one species. There is no such thing as the bite force of an alligator snapping turtle. In the same way, there is no such thing as the grip strength of a human being. There is a curve, and the animal's size tells you where on the curve it sits. And the paper's own conclusion is the part almost nobody repeats. Alligator snapping turtles produced higher maximum bite forces than common snapping turtles throughout their lives, and the reason the authors give is that alligator snapping turtles reach significantly larger maximum sizes. So the mechanism is size, not a special jaw, not a different class of muscle, not some evolutionary weapon the common snapper missed out on. Just decades of extra growth applied to the same basic equipment. Which is a stranger fact than the one the internet is selling you, and honestly, a more useful one if you fish. That common snapping turtle in the pond behind your house is running comparable hardware for its size. The alligator snapper just keeps growing for decades longer. And here's what I keep coming back to. This animal almost never needs the top of that curve. Everything you just heard about the lure exists, so that the jaws close on a fish that already swam into them. A turtle sitting motionless on a bayou bottom with a pink flap moving in its mouth has already done the hard part of the job by the time the jaws are involved at all. The jaws only handle the last half second of it. Subscribe here if you are going to subscribe anywhere in this video. The last stretch is about how few of these are actually left in American water, and that number lands harder than anything in the bite force papers. Because for all the talk about how dangerous it is, the paperwork tells a very different story. In 2005, the United States moved to include the alligator snapping turtle in Appendix 3 of CITES, the international convention that regulates trade in wildlife. That notice ran in the Federal Register on December 16, 2005, and the listing took effect on June 14, 2006. The International Union for Conservation of Nature classifies the species as vulnerable. In Florida, it is protected as a state species of special concern under the state's Endangered and Threatened Species Rule, and under Rule 68, a 27.005 of the Florida Administrative Code. It is flatly illegal to take, possess, or sell one, and in 2024 it went further. On June 27, 2024, the U.S. Fish and Wildlife Service published a final rule listing the Suwannee alligator snapping turtle, a separate species found in the Suwannee River Basin in Florida and Georgia, as threatened under the Endangered Species Act, with a Section 4D rule attached. It took effect on July 29, 2024. The entire species, one population, is estimated at roughly 2,000 individuals, 2,000 animals. That is the entire species, in one river basin in 2 states. The damage came from 2 directions. Florida's Wildlife Commission points to heavy commercial harvest for meat, peaking through the 1960s and the 1970s, which knocked regional populations down hard. And it points to the quieter one that never stopped, which is bycatch. Trot lines, long submerged runs of baited hooks, and bush lines, single hooks hung off branches, both set for catfish, both sitting in exactly the water where these turtles live. The turtle takes the bait, and that is the end of it. Now, stack that against how this animal reproduces, because this is where it gets genuinely hard to fix. Alligator snapping turtles reach sexual maturity somewhere around 11 to 13 years old. A female lays 1 clutch a year, somewhere between 17 and 52 eggs, buried in sandy soil, usually within about 65 feet of the water. The eggs sit for 100 to 110 days. And the sex of every hatchling is decided by the temperature of the nest, not by genetics. Cooler nests, around 77 to 81 degrees Fahrenheit, produce males. Warmer nests, around 84 to 86 degrees Fahrenheit, produce females. So you cannot rush this species back. A turtle that hatches on a Louisiana sandbar this August will not breed until sometime in the late 2030s, and only if it makes it that far past the raccoons, the wild hogs, the fire ants, and every catfish hook in the parish. Which is why the last few years have been spent mostly on one question: how many are actually left, and where? Texas ran the biggest version of that. Between 2021 and 2023, the Environmental Institute of Houston at the University of Houston Clear Lake carried out a statewide trapping program for the Texas Comptroller of Public Accounts, working the major East Texas river basins inside the animal's known range: the red, the sulfur, the Sabine, Cypress, the Angelina, the Neches, the San Jacinto, the Trinity, the Navasota, and the Brazos. Seasonal trapping, at least 1 visit per season at every site. The final report ran to 107 pages, and the stated reason for doing it at all is worth hearing. Until that project, Texas had exactly 1 long-term population study of this species on the books. 1. For a turtle that occurs in 10 river systems across the eastern half of the state. And when the genetics came back, a 2024 presentation from that same group described strong divergence between Texas populations and low effective population sizes, which in plain terms means the turtles in one river are not exchanging with the turtles in the next river, and there are not many of them doing the exchanging. There is one more thing on that project page that tells you where this stands. The Sabine River Authority runs a public reporting page called "Have You Seen This Turtle?" The Trinity River Authority has a sighting report form. The water district covering the Cypress, Sulphur, and Red basins runs one called Turtle Alert. River authorities in Texas are asking members of the public to tell them when they see one, because that is genuinely useful data now. People have also tried putting them back, and there is a real experiment on the ground in southwest Louisiana worth knowing about. The Louisiana Department of Wildlife and Fisheries ran a Head Start program, raising young alligator snapping turtles in captivity past the most dangerous stretch of their lives, then putting them in the water. Between November 2015 and October 2016, they released 53 head-started juveniles at 7 sites along roughly 3.5 miles of Bundick Creek in Beauregard Parish. Every turtle was measured, weighed, and tagged before it went in. In 2018, the U.S. Geological Survey went back to those same 7 sites to see what had survived. 1 week of trapping at each site. What came up was 69 turtle captures across 7 species, and among them, 15 alligator snapping turtle captures representing 12 individual animals. 8 of those 12 were head-started turtles. 4 were natives that had been in that creek all along. The researchers put the minimum survival rate of the released turtles at 17%, and the ones they caught were mostly still sitting near where they were dropped, growing at a normal rate. Which is the good news. Here's the part that stuck with me. 3 of those head-started turtles had their external identification tags caught in the mesh of the survey nets. 2 of them drowned. These were animals that had already survived 2 years in the creek, killed in a net by the tag that was supposed to track whether they were surviving. On the strength of that finding, Louisiana discontinued external tags on head-started turtles altogether. And a year later, in 2019, another survey went through south-central Louisiana, sampling 8 field sites where these turtles were either known from the past or simply unknown. They caught, measured, and marked alligator snapping turtles at 4 of the 8, 4 out of 8, in Louisiana, which is the heart of this animal's range. So go back to the Atchafalaya and put all of it together. The water is opaque, the shell is covered in algae and reads as bottom. The mouth is lined gray and brown, so nothing inside it looks like a mouth. The one visible thing is a pink piece of tongue that the turtle grew for exactly this purpose and almost never damages, and it is moving right now, in water that has boats running over it. Nobody standing on that bank will see it. Nobody swimming past it will feel it. And the reason for all of that is the same reason biologists have to set traps for a week to find out if it is even still there. It does not move. That is what makes it so good at feeding itself. And that is what lets it disappear out of an entire river system without anybody standing on the bank ever noticing it was gone. If you want the opposite problem, the animal in these same rivers that everybody does see and still gets completely wrong, that one is on screen now.